Hello grade 9 students. Welcome to another virtual class. I am Miss Madhu Badke. We are studying chapter 12, Heron's formula, and we have learnt all the concepts in this chapter. We learnt various types of formulas that can be used to find the area of different types of triangles depending on the data that is given. However, we need to explore these concepts a bit more. So in today's video lesson, we are going to do some extra questions which are based on 2 or 3 concepts taken together. Or in simple words, to solve these questions, we will need more than one formula. So let's try solving these type of questions. Question number 1. In a triangle ABC, AB is 15 centimeters, BC is 13 centimeters and AC is 14 centimeters. Find the area of triangle ABC and hence its altitude on AC. Since 3 sides of this triangle are given, we can find the area of this triangle using Heron's formula. So the first step is to find the semi-perimeter, which is A plus B plus C divided by 2, that is equal to 15 plus 14 plus 13 divided by 2, that is 42 on 2 equal to 21 centimeters. So the area of this triangle is equal to root of S into S minus A into S minus B into S minus C. Substitute the values of S. We have found S as 21. A, B, C are 15, 14 and 13 centimeters. So after substitution, simplify this expression. We get 21 into 6 into 7 into 8. 21 can be written as 3 into 7, 6 as 2 into 3, 7 is a prime number, 8 can be written as 2 into 2 into 2. Now write pair of factors that are identical. So 3 into 3, I have written these two. 7 into 7, I have written these two. 2 and 2 and another pair of 2. So now these numbers can be written out of the square root as 3 into 7 into 2 into 2. On multiplying, these numbers will give 84 centimeters square as area of this triangle. The second part of the question is find its altitude on AC. Altitude on AC is a line drawn from the opposite vertex B perpendicular to AC. Let's mark the altitude as BD. So we have to find the length of BD. Now in this part of the question, we will have to use the other formula for the area of triangle, which we had learned in the first video of this chapter. Area of triangle can also be given by half base into height. So if I take the side AC as the base, then BD will be the corresponding height. So we can find the area of this triangle as half AC into BD. Now we have already found the area of this triangle using Heron's formula. So we are going to substitute over here in this formula and then find. So area of triangle is also equal to half base into height. The base is AC as we have to find altitude to this base, which is given as 14 centimeters. So 84 is equal to half into 14 into h. Now rearranging this, we get h equal to 2 into 84 divided by 14. 14 6 times is 84. So 6 2s are 12. So 12 centimeters is the height corresponding to the base AC. Notice that we have used two formulas. One to find the area of triangle using Heron's formula, and the other again area of triangle but a different formula to find out the height of the triangle. So in this formula, if we denote the area by A, the base by B, and the height by h, then we can rearrange this formula to find out h. 2 times A will be equal to B into h, or h will be equal to 2A upon B, that is the base. So we can find the height of the triangle by dividing 2 times area by the corresponding base. Question number 2. A triangle has sides 35 centimeters, 54 centimeters and 61 centimeters long. Find its area. Also find smallest of its altitudes. So the first step is to find the perimeter. That will be A plus B plus C divided by 2. So 35 plus 54 plus 61 divided by 2 will give 150 divided by 2, which is 75 centimeters. So the area of this triangle is equal to root of S into S minus A into S minus B into S minus C. On substituting, we will get root of 75 into 75 minus 35 into 75 minus 54 into 75 minus 61. Simplifying each bracket, we will get root of 75 into 40 into 21 into 14. Now we will factorize each of these numbers. 75 is 25 into 3, so that is 5 into 5 into 3. 40 is 4 into 10, and 10 is 2 into 5. 21 is 3 into 7. 14 is 2 into 7. Let's write pairs of identical factors. So we have 5 into 5. We have 3 into 3. We have 4, and 2 into 2 will be another 4. We have 7 into 7. And 5 is left alone. Now we can write the square root for each of these pairs. So 5 into 3 into 4 into 7, and 5 will be written under the square root sign. So multiplying these numbers, we will get 420 root 5 centimeters square. So we have answered the first part, that is the area. Now we have to find the smallest of its altitudes. There are 3 altitudes in a triangle because there are 3 vertices from which perpendiculars can be dropped to the opposite sides. But how do we know which altitude is the smallest? Using the formula that we just derived in the previous question, height of a triangle is equal to 2 times area divided by the base. We can find which altitude is the shortest. Notice that in this formula, base is in the denominator. That means height is inversely proportional to the corresponding base. So, if base is a larger number, then the height will be smaller. So, the smallest altitude will correspond to the largest base. So, here the longest side is 61 centimeters. So, an altitude from the opposite vertex to this base will be the shortest altitude. If we are asked which is the longest altitude, then it will correspond to the smallest base. So, in this triangle, the longest altitude will correspond to the base 35 centimeters and the shortest corresponds to 61 centimeters. So, this means that to find the smallest altitude, we are going to take the base as 61. So, height of this triangle is 2 times area divided by the base, where the area is 420 root 5 and the base corresponding to the smallest altitude is the longest side of the triangle. So, that is 61 centimeters. So, this is 840 divided by 61 root 5 centimeters. Question number 3. The length of the sides of a triangle are in the ratio 3:4:5 and its perimeter is 144 centimeters. Find the area of the triangle and the height corresponding to the longest side. In this question also there are 2 parts. We have to find the area and then the height corresponding to the longest side. Since the sides are in this ratio, we can assume a common factor and say that let the sides be 3x, 4x and 5x. So, sum of these sides should be equal to the perimeter and that is given as 144 centimeters. On adding the left hand side, we get 12x equal to 144 centimeters. So, x is equal to 144 divided by 12. So, x is equal to 12 centimeters. Therefore, the sides of the triangle are, let's say the first side is 3x, which is A. That will be 3 times 12, that is 36 centimeters. B is 4x, that is 4 times 12, that is 48 centimeters. And C is 5 times x, so 5 into 12 is 60 centimeters. So, now we have all 3 sides of this triangle and the longest side is 60 centimeters and we have to find the height to this side. So, we follow the same method that we did in the previous question. Find the area using Heron's formula. So, for that we will have to find the semi-perimeter, which is P upon 2. Perimeter is given as 144 divided by 2 will give us 72 centimeters. So, the area is equal to root of s into s minus a into s minus b into s minus c. Substituting, we get root of 72 into 72 minus 36 into 72 minus 48 into 72 minus 60. So, we have 4 numbers under the square root, that is 72 into 36 into 24 into 12. Now, factorize each of these numbers. 72 can be written as 12 into 6, 36 can be written as 6 into 6, 24 can be written as 6 into 4 and 12 we will write as 3 into 4. We can further write 12 as 3 into 4. Now we will write down the pairs of identical factors. So 3 into 3, 4 into 4, 6 into 6, another 6 into 6, and this 4 we will write as 2 into 2. So for each pair we can write down its square root. So we get 3 into 4 into 6 into 6 into 2. On multiplying, this is 864 centimeters square. We have to find the height to the longest side, that is 60 centimeters. So the formula will be 2 times area divided by the base, that is 2 into 864 divided by 60. On simplifying and dividing, we will get this as 28.8 centimeters. So we have learned today 2 new concepts. 1. The formula for the height of the triangle is 2 times the area divided by the corresponding base, and the shortest height will correspond to the longest base, and the longest height will correspond to the shortest base. With this, we come to the end of this video lesson. Your assignment for today is to solve these 2 questions, which are similar to the questions that we have done in today's video lesson. See you in the next class. Until then, goodbye.